All right, welcome. So you've already figured out how to write down instructions for a game using algorithms. Well, today, we're going to level that up. We're going to learn how to draw the master blueprint that turns all those written instructions into a visual plan. Let's get into it.
Okay, let's dive into the mission. You've tackled algorithms and pseudocode, but now it's time for the next level. You're about to unlock the secret visual plan, the master blueprint that's behind every single great video game.
So, your mission, should you choose to accept it, is to master the art of the game blueprint. See, in the coding world, we call this a flowchart, and trust me, it's the ultimate tool for turning a cool idea into a logical plan that a computer can actually understand and run.
So here are our objectives for today. We're going to see how flowcharts handle game logic and even cybersecurity. We'll also zero in on two key skills. First, decomposition, which is just a fancy way of saying we'll break huge problems into tiny, manageable steps. And second, reflectiveness, which means planning out our logic before we even think about writing a single line of code. Let's get these skills unlocked. But first, a little cautionary tale. Before we start building anything, we really need to understand what happens when a plan goes horribly wrong. I'm talking about what happens when your game gets stuck forever.
No, seriously, think about it for a second. Every good story has an ending, right? Well, so does every game. The logic has to know when to stop. But what if it doesn't? What if there's no game over screen? What happens then?
This is exactly what happened to Sheldon Cooper in The Big Bang Theory. He made this thing called the friendship algorithm. Yep, a flowchart for making friends. But his plan had a huge fatal flaw. He got stuck in a loop with no way out, just repeating the same step over and over and over again. And this is just a perfect example of the problem and, more importantly, the solution. On the left, you've got the problem. Sheldon's logic would just ask the same thing forever and ever. But on the right, you see the fix. You add a limit, a loop counter, and you give it an escape hatch. Every single loop has to have a clear exit, or the whole program can just crash. That's a super important lesson we've got to remember.
Okay, so how do we avoid getting stuck in our own friendship algorithm? Well, we use a power-up, and that power-up is the flowchart. Think of this as our essential game design toolkit for building a perfect plan.
And you know what's so cool about this? Your whole toolkit is basically just these three simple shapes. The oval, that's your start game and your game over. The rectangle, that's for any action, like score +1. But the real powerhouse here, that's the diamond. This is where your program asks a yes or no question and actually makes a choice.
Now, like any good game, there are some rules you got to follow. First off, you always need a start and an end. The flow of logic only ever goes one way. And every decision diamond needs at least two ways out, a yes path and a no path. And please, no floating parts. Everything has to connect. You follow these rules and your game's logic will never get lost.
All right, time for the main quest. We're going to take this new toolkit of ours and put it to the test. We are going to design the blueprint for a total classic, the chasing game.
Okay, this right here, this is the very heart of our game, the core logic loop. It kicks off by setting up our player, our cherry, and the score. Then bam, we hit our first decision point. Has the player touched the cherry? If the answer is yes, we run a process. Add 1 to the score and teleport the cherry somewhere else. Then we hit the second, absolutely critical decision. Is the timer at 0? If no, we loop right back up and ask the first question all over again. But if it is yes, boom, game over. See that? That's our escape hatch. No infinite loop for us.
All right, you've seen the plan, you've learned the rules. Now it's your turn to jump in, complete the mission, and prove you've mastered this skill.
So, to prove you've completed this mission, you need to collect a few items for us. We need to see screenshots of your finished game, your pseudocode planning document, and, most importantly, the flowchart that you designed. This is the proof that you can plan your logic before you build.
But hold on, we're not done yet. There's a bonus level. That blueprint you just made, it's way more powerful than you might think. It's not just for chasing cherries. Let's see how that same logic can be used to defend an entire computer network.
Just look at this for a second. It's the exact same logic, just with a different skin. Your player is now a shield hero. The cherry is now a virus. The score tracks how many viruses you've stopped, and the timer, that's how long the system can stay up before it crashes. The game plan you made is now a defense map. The core logic, the structure, it's identical.
And that's the big idea I really want you to walk away with. You're not just making a game. You are learning the powerful skill of logical planning. The same blueprint you use to chase a little cherry can be adapted to solve real-world problems.
So as you're building your game, keep this question in the back of your mind. How can my flowchart become a defense map? Good luck, Player 1.